Alright, so today we're going to look at Unit 1, Lesson 3, Investigation 1, Solving by Graphing. Now, to get started, we made this equation off of page 49, right? You guys created this equation, and we solved for I and D using what method? What method was this, guys? Substitution, right? So what's on the board right now is solving using substitution, okay? Now today we're going to look at solving by graphing, okay? Now, if I look at these two equations, these equations are said to be what type of equations? What are they going to make if I were to graph them?
Parabolas.
They make parabolas. Yeah? Is Rock right? Would they make parabolas? No. No, because parabolas need an x squared, right? Is anything squared in here?
No.
No. So what are these going to make? They're going to make lines. Right? So when we first learned substitution, I told you we were solving a system of what type of equations? You remember? Linear equations. So the other day when we learned substitution, I told you we were solving a system of linear equations by substitution. Today we're solving a system of linear equations by graphing.
Is this easier?
What?
Is this easier?
Depends on the person. You said you hated graphing earlier, so it might not be. Okay.
Is it shorter?
Is it shorter? Depends. Okay. I mean, graphing isn't my go-to way to solve. Okay. But there are certain equations I think that would be easier to solve using graphing. Okay. It all depends on how the equations look when you first get them. Okay. So solving a system of linear equations. All right. So we said these two equations will really make a what? Each of them will make what?
Line.
A line, right? So each equation will form one line, right? So if I have two lines, right? How many times can they intersect? Once. Two lines can only intersect once, right? Can they intersect 0 times? Yeah. Could they intersect an infinite number of times? Yes. If I actually have two lines that are exactly the same, they intersect an infinite number of times. So if I have one line and the other one goes right on top of it, that'd be an infinite number of intersections. Okay? But so far, we're just going to look at where they intersect one time. Okay? So two lines will intersect once. Right? Two lines will intersect once. Okay. What do you think that intersection is for our problem? What is it? The solution. Okay? The intersection is the solution.
So is it going to be kind of like the same, like trying to find x and y, but where it intersects on the x line and where it intersects on the y line?
Mm-hmm. Well, not on the x line and the y line, but where it is, where that point is in the coordinates. So let's say I have two lines. I have one that looks like, let's say I have one that looks like this, okay, and I have another line that looks like this. Right? How many times do they intersect? Once. This point right here, this is the intersection, right? That point would be our solution. Okay? This point represents the solution. Okay? That point is the solution. Now that point will have an ordered pair, right? Right? What is that ordered pair? What comma what?
X comma Y.
X comma Y. Okay. Whatever the first number is, that's our X solution. Whatever the second number, that's our Y solution. Now, why is that intersection our one solution? What has to be true about our solution? It has to do what to both equations?
It has to be true.
Has to make both equations true, right? Right? So when I find the intersection of two lines, That's the one point that's on both lines, right? That's the one point that's in both tables, right? That's the one point that makes both equations true. Okay? So the intersection is the only point that makes both equations true. And that's why it is our one solution. Now, in order to graph something, what form does it typically have to be in? What is it? Okay, Johnny, you said it? Or is it Alyssa that said it? What form? Perfect. Okay? It has to be, in order to graph something, we need to have y equals mx plus b. Right? M's the slope, b's the y-intercept. That's the form it has to be in order to graph, right? So we need our equation like this to graph. If it's not like this, we can't graph it. Okay? Now there are two ways you can graph something. You can use your calculator or by hand, right? Or we can draw an axis and go by hand, right? So we can graph by hand, which means either drawing axes or using graph paper, right? Or we can use the calculator. Now, if I graph something by hand, is it going to be really accurate?
No.
Okay. What if I use graph paper?
It may.
Better. A little bit.
Be a little better, right? What if I use a graph paper and a ruler?
Yeah.
Even better. But will it be exact?
No.
No. Was substitution exact? Yes. Substitution's exact. Is graphing by hand exact? No. What if I use my calculator?
Well, what do you mean by not exact? Because if it's a point, then obviously you know where it intersects at.
Right, if it's a good point, right? Okay. But is it possible for me to make a graph and like let's say I make some dots, and if I hit all my dots right down the center, that's exact as I can be, right? But when we make graphs, are we always hitting every dot right down the center? Sometimes we hit them off to the side, right? Sometimes our dots are a little off, right? So even if it crosses that line, that might not be the exact answer, even though you think it is. Okay, so it crosses like at the, so it crosses like let's say this says like 1, 2, 3, 1, 2, 3. So it crosses at 3, 3. Just because it crosses there when I graph it by hand, doesn't mean that that's actually where it crosses. That just could be the approximation that I got from graphing. Does that make sense? Okay. Same with your calculator. Is your calculator more exact than graphing by hand? Yeah. Yeah, it's a lot more exact, right? If I look at the window of my calculator, is it possible that I'm still off?
Yeah.
Yeah, because your calculator has pixels in it, right? Right? The lines aren't always smooth, are they? So if I use those pixels, I might be off. Now there's something we can use on the calculator that makes us a little more exact, and I'll show you how to do that today. But still,
You're off.
by a little bit.
So the table
Okay.
makes it sure.
Well, the table, if I try to use a table to find the overlap, our tables only go to like 3 decimal places, right? So is that exact if I had a really big decimal? No, and plus the table, Faith, is going to take a really long time. So I would never use a table to find a solution. It's going to take way too long. All right. So the problem with these two, both by hand and by using calculators, they are approximations. They're estimates. Okay. They are approximations. They are estimates. Right? By hand especially is an approximation. The calculator is a lot closer. So Josh, even though you might like this method better, okay, I wouldn't use it every single time. Okay. Now I would use it to get close, and then maybe figure out from there. But we'll see as we go through. Okay. All right. Are there any questions? Giving you guys a pink handout. Jordan, can you lights for me, please? Or Rebecca, or Lon, or somebody, or Lisa. Somebody. Look at all this technology. Okay, hopefully the camera can pick it up. All right. So here I've given you guys a graph of this of this situation. Okay. Look at the top. We have 16x plus 10y equals 240, and we have x plus y equals 18, right? Right. Sorry about the drone. And we have x plus y equals 18, right? Now what do they do here?
They graphed them both on the thing.
They graphed them both, right? So they found the solutions, they plotted them, made two lines, didn't they? Okay. Is this a good graph?
No.
Yeah, I think it's a good graph. It's computer generated, right? It should be pretty accurate, shouldn't it?
No.
No?
Yeah.
It might be close, right? Okay, let's take a look at how close it is. First, though, let's match the graphs to their linear equations. Because we said that these things make lines, right? So that means one line should be one graph, the other line should be the other graph, right? So, one line should be one equation, the other line should be the other. So line 1 starts at like somewhere between 22.5 and 25. Ends down here at about 15, right? Which one do you guys think is line 1? 16x plus 10y equals 240 or x plus y equals 18? Yeah. Yovanink thinks it's this one.
Yeah.
Yeah?
Yeah.
Okay, we don't seem too sure of ourselves. Let's look at the other one. Okay? This one starts somewhere beyond 17.5. What do you think that something beyond 17.5 is? Get a guess. 18. Okay, so that one is at 18 down here. What is it up here? 17.5, right? So that's probably 18, isn't it? Right? Those are both probably 18, aren't they? So that means that when x is 0, y is 18, correct? When y is 0, x is 18. Which graph is this? The second one, right? So line 2 is x plus y equals 18. Which means line 1 is 16x plus 10y equals 240. Right? Does that make sense, guys? Yeah. Now, in general, if we had to make these equations, or make these graphs, could we use the equations like that, or should we solve for y equals mx plus b? We could use those and find solutions, but it might be easier to do mx plus b and use our calculator. B. Use the graphs to estimate the solution for the system of equations. Remember, the solution is values of x and y that satisfy both equations. Explain what the solution tells you about the science of fundraising. So, using this graph, where's the solution?
On the intersection.
On the intersection. Good. Where's the intersection?
Approximately right there, but it's really kind of
Like right there, kind of, right? A little bit to the left of 10, a little bit above 7.5, right? Right? So what might you think this point is?
solution.
10 comma 8?
No.
0,
7. I was say more of 7.
2.5,
It's
right? 5, 7.5, 10. So it's just above 7.5, which means it's probably closer to 8. And it's just to the left of 10, which means it might be 10. Okay? Now, you guys already solved this, didn't you? You guys already solved this using substitution, didn't you? What'd you guys get? What'd you guys get as your answer? Faith, head up. Maddie, head up. Jordan. What is our solution?
10 and 8.
10 and 8, right? So using substitution, we knew for sure that our answer was 10 and 8. Using graphing, it's kind of close, right? Okay. So even though I'm a computer-generated graph, it's still not exactly on 10, 8. Okay. What does that mean? What does 10 mean? 10 is the indoor or outdoor workers?
Outdoor.
Outdoor. Okay, that's because my x-axis is D, and my y-axis is I. So 10 is my outdoor workers, and 8 is my indoor. So for B, the solution 10, 8 tells us we need 10 outdoor workers and 8 indoor workers to get to meet our income goal. C. Since the graph gives only since the graphs give only estimations for solutions of equations, it is important to check the estimations. Show how your graph-based estimates can be checked to see if it is an exact solution to the system. So how can I check my graph-based answers? What could I use? What is it, Rebecca? What is this method called?
Solution to, I don't know.
Okay, that first method we used was substitution. So if I use substitution, then we can check to make sure that our graphing answer is correct. Okay? So the problem with using graphing, Ethan, is that you might end up with an estimation, which then you might have to use substitution anyways. Okay, does that make sense, guys? Yeah. Are there any questions? Any questions?
So we have to do both along just to make sure that they.
You might have to, okay? Unless you know for sure, okay? Now, if you get whole number answers, then you probably know for sure, okay? Especially using your calculator. If you get whole number answers using your calculator, then you probably know that it's for sure the right answer, okay? But if you get decimals using your calculator, then you might want to try another method, okay? And that's the problem with graphing, is sometimes you might have to do two methods. It's a little easier, Josh, but sometimes you might have to use two methods, right? All right, Ethan, have it, please. Thank you. Yeah. You guys must have like turkey for lunch or something. Yeah, because it has L-tryptophan in it. It makes you sleepy.
No.
Yeah, there's a chemical.
I didn't mean
Thanksgiving.
turkey.
Yeah, there's a chemical in turkey that makes you sleepy. All right. Any questions about that paper? No. Okay, you guys can just hold on that paper. You don't need to. Let me turn it back in. All right. All right. So, no, we're not done. Does anyone want to learn how to solve using graphing? No? Long, can you get the light screen, please? Take that long walk and hit the lights. All right, so let's learn how to solve using graphing. Okay. Well, was a knee slapper or something? So long, take that long walk so you get the lights. Okay. All right. So just like how we had steps to solve for substitution, we have steps to solving using graphing. Okay. Now, if I'm going to graph something, what form does it need to be in again?
Linear. MX plus B.
Y equals mx plus b, right? So what do you think our first step is?
Solve for
What do you think step one is?
this equation twice.
What is it, Yoni? Okay. Write the equations in. Mx plus b, 4. Now, that is part of the first step. But in our situation where we have 18 equals I plus d, and 240 equals 16d plus 10i, right? Do we have x's and y's? No. We have i's and d's, right? So we run the risk of writing them incorrectly if I don't pick which variable is going to be my y first. Okay? So our first step, guys, is to pick a y. So pick a, I'll put y in quotes, okay, because there is no y in this problem, but I'm going to pick something to be the y, okay? Pick a y. Right? So what do you want your y to be in this case? I? Or someone say D? Does it matter?
Yes.
No, it doesn't matter.
That's what the app
Okay.
does.
So we're going to say that y is I.
Is that 18 or 8? I mean 1.8.
18.
I didn't ask you.
Okay.
But I told you.
Guys, so we're going to say y is I. Then once I pick my y, what am I going to do with these equations?
Rewrite it with
We write each equation in y equals mx plus b form. Right? So since I want y to be I, what am I solving for? What do I need to solve the two equations for? I. We need to solve the two equations for I. So we have 18 equals, oh, different color, sorry. Breaking my own rule from last time. So here's the steps, and here's what the process looks like. Okay. Now on your notes, you might want to draw a little squiggly line right here so you don't get your two equations confused. Squiggly line.
I moved out straight line.
Okay, straight line's fine too. So I'm going to solve that first equation for I. What do I do? I'm going to solve that first equation for I. What do I do? Subtract what? No. Subtract B. What? 18 minus D equals I. Does that make sense, guys? Okay. I'm going to take the second equation. I'm going to solve for I. So what's my next step? So we need to subtract 16D. So we get 240 minus 16D equals 10I, right? What do I do now? Divide 10 by both sides. So these cancel, we get I. 240 divided by 10 is 24. 16 divided by 10 is 1.6. Now, in your calculator, y is usually on the left, isn't it? Y equals on the left. So I might want to rewrite these like this, with the I on the left. But it's okay for me to flip them because I flipped both sides. Now these are my two results. Okay, because if we solve for D once, right, then we'd have I equals D, where I is my Y and D is my X, right? If I solve for D once, then D would be my Y and I would be my X. So my axes wouldn't be the same. Does that make sense? So I want to solve for the same variable both times. That way, my Y is always I and my X is always D. Okay, good question. Next step. Graph. Okay. Okay. Graph. Graph both equations. Okay. And you can either use your calculator or you can graph by hand. Now I'm hoping you use your calculator. Okay. Oh, that's step 2, not step 3. My fault. I can't count. Goodness. Step 3. Okay. Oh, let's get to that graph stage. Can't skip myself. We'll graph right now. All right. So everybody take your calculators out. This is why I wrote them in y equals mx plus b form. Okay. Because now I can use my calculator. I have a pink one.
It's not his.
I'm okay with it.
How you doing?
Good. How are you?
Good.
Okay. What calculator do you need?
Number 18.
Number 18. Why don't you for class time?
Because I knew about it, and I came with, like, barely on time.
It's math class, right?
Why is it pink?
Why? Because it's my score and stuff. And I think you got a deal on
It
it.
says they explain why it's pink.
Okay. So, we're going to first do.
I can't see.
Can't see? Rebecca, can you light to me, please?
Why is there one
Mom is gonna take the long walk.
Shut up.
Why is there one? Because it was one that was. It was one that was
Way to
thrown
go.
away. Or not thrown away, but just taken out because someone drew on it by accident. And mine broke earlier this year. They gave me this one instead.
No, I'm talking about the one shown on the screen.
I know, right there. I just explained it to you.
Oh.
I'm gonna
I
have to
remember
check.
Cocoon.
All right. So, guys, first thing I do is I hit zoom 6. So you know you have a good look at your graph. Okay? Now we're going to plug our equations in. Okay? Now, our equations were 18 minus I, right? So instead of I, use X. And the other equation, 18 minus D, not I. 18 minus D. And the other one was 24 minus 1.6 D. So instead of D, I use X. Okay? So those are our equations. All right? Any questions?
No.
Okay. Now when I hit graph, I get something that looks like this. Okay? Can you see your intersection? No. So what you're going to want to do is you want to make your window a little bigger. Now, do we need these quadrants down here? No. So we do not need negative x, and we don't need negative y. So if you hit window, it's the button right next to y equals. We don't need negative x anymore, so I'm gonna have negative 1 be for my x min, and I'm gonna have negative 1 be my y min. Okay. Now my x max, I want to be a little bigger, don't I? So I'm just gonna arbitrarily pick a number. I don't need a lot bigger, just a little bigger. So I'm gonna go 30. Okay. Okay, the y max. I don't need a lot bigger, just a little bigger. I'm gonna go 30. Now I hit graph. Now here is a good graph of our situation. We can find the intersections right here, and if you count either way, then you can get your x and y's, can't you?
Yep.
Okay. But that's just going to be an approximation. So, to use our calculator, the way to use our calculator to get our answer, right? We need to find the intersection. And the way you do this is you hit second, trace. Okay? And what that equals is they'll give you the calculator menu. So hit second, trace. Second, trace. And if you look at the fifth one, what does the fifth one say? Intersection. So you hit button 5. So hit 5. And now it says y equals 18 minus x at the top. That's our first equation, right? So I hit enter. Y equals 24 minus 1.6x. That's my second equation, right? So I hit enter. Now it says guess, because remember this is an approximation. I hit enter. And what does it tell me? 10 and 8. It tells me that 10 outside workers, because x is d, right? And 8 inside workers. So once you do this, you hit enter how many times? Hit enter 3 times, and it'll tell you your answer. Now the problem with this method, guys, is if I'm outside of my, if my intersection is outside my window, it won't work. All right? So you've got to be able to see your intersection in your window in order to get the answer. Right? Does that make sense?
Yeah.
Yeah?
We're done?
Yep, that is it today, Long. Yeah. We'll practice that tomorrow, all right, because we're about short on time. Good job today, guys.